All right, first topic in our new unit is sequences, which are patterns. So our first activity is just recognizing different patterns, whether it's a picture of a pattern or a word problem that contains a pattern. We have these little pluses made up out of these dots here. And we need to analyze the number of dots and describe the pattern. Okay, so take a minute, look at these pictures, come up with something you're noticing about these dots or the number of dots. All right, good. Now that we had a second to think, maybe you looked at it and you saw, well, from this first picture to the second picture, we lost a dot. And then from the second to the third picture, again, we lost a dot on the outside, so on and so forth. So maybe that's what our pattern is. If you were looking at it maybe from a numbers standpoint, this picture had 25 dots, this one had 21 dots, 17 dots, 13 dots. So each picture had 4 fewer dots than the one before it. So however you wanted to describe that pattern, write that in for part A. I said each figure has 4 fewer dots than the one before it. Part B says draw the next 3 figures of the pattern. So this one had 13 dots, and we know that the pattern is each figure has 4 fewer dots than the one before it. So our next figure is going to have 9 dots. And it looks like I have 1, 2, 3 dots. 1, 2, 3 dots, 1, 2, 3 dots, 1, 2, 3 dots, and 1 in the middle. So for the next picture, I'm going to have 1 dot in the middle with 2 dots on top, 2 dots to the side, 2 dots down below, 2 dots to the other side. So I have 1 dot in the middle, 2 above it, 2 to the side, 2 below, and 2 to the other side. And then the next picture is going to have just the 1 dot in the middle and 1 on each side of it. And then the next picture is just going to have 1 dot. Part C asks us to represent the number of dots in each of the 7 figures as a numeric sequence. Numeric is just numbers, sequences, well, what's the pattern of numbers? So our first figure, we already said, had 25 dots. The next picture had 21, 17, 13, 9, 5, and 1. So we decreased by 4 each time we went to the next figure. And then part D, nothing new here. We're just representing the number of dots in a different way. We're going to put it in this table of values. We're going to put it in this table of values. So we have term number. First term of the sequence, second term, third term, fourth term, fifth term, sixth term, seventh term, and the value. So the first term is 25. The second term is 21, third term is 17, fourth term 13, 9, 5, and 1. So if we were asked, well, what's the 5th term in the sequence? What's the 5th picture going to look like? Right here, there's going to be 9 dots in the 5th term of the sequence. Moving on to the next one, I know that it says number 4, and we're really not on number 4, but these pictures were just taken right from the book, and I didn't edit out the number. So, Al's omelets. Al's house of eggs and that makes omelets. Al begins each day with 150 eggs to make his famous Western omelets. After making 1 omelet, he has 144 eggs left. After making 2 omelets, he has 138 eggs left. After making 3 omelets, he has 132 eggs left. For part A, think about the number of eggs Al has left after making each omelet, and then describe the pattern. So after he makes his first omelet, how many eggs does he have? After the second one, how many eggs? Third, how many eggs? Think about that pattern. So how would you describe that pattern now? Well, I said Al has 6 fewer eggs after making each omelet. You could also say that Al uses 6 eggs to make each omelet. Either one would work for this. Part B, determine the number of eggs left after Al makes the next 2 omelets. So when Al makes his 4th omelet, how many eggs will he have? Well, each omelet takes 6 eggs. After the third one, he had 132 eggs. So 6 eggs less than that is 126 eggs left. And make sure that you're including your units. Otherwise, 126, what is that representing? I'm not sure. And then after the 5th omelet, how many eggs does he have left? Well, 120 minus the 6 eggs that it takes to make an omelet, he'll have 120 eggs left. So we want to represent the number of eggs that Al has left after making each of his omelets. So after the first omelet, we have 144 eggs. After the second omelet, we have 138. Third omelet, 132, 126 after the fourth, and after the fifth, we'll have 120. So now we need to represent this in the table of values. Term number is always going to be just 1, 2, 3, 4, 5. And we'll list 144, 138, 132, 126, 120. So after the first omelet, he has 144. After the second omelet, he has 138. After the fourth, 100. So after the first omelet, he has 144. After the second omelet, he has 138, so on and so forth. Till we get to after the fifth, he has 120. Now, some of you might be wondering, well, they told us 150. What does that number of eggs have to do with anything? Well, this is our initial term. This is what we would call our zero term. Zero term is what we start with, which is 150. So if we were looking at this as a graph, remember where these are our x values, these are our y values, and maybe these are all ordered pairs. This 0, 150 would actually be our y-intercept on that graph. And we will be graphing these, not today, but in another lesson we'll be graphing these. So if you kind of understand that concept, you'll be in really good shape for when we start graphing these. All right, then the third one, which is actually number 9, our pizza contest. Jacob is participating in a pizza making contest. Each contestant has to bake the largest and most delicious pizza they can. Jacob's pizza has a 6-foot diameter. After the contest, he plans to cut the pizza so that he can pass the slices out to share. He begins with 1 whole pizza, then he cuts it in half, and after that, he cuts those into halves, and then into halves, and then into more halves, and so on and so forth. Okay, so if you need a visual of what's going on because that really confused you, that's totally fine. Let's draw a picture. Okay, so pizzas are circles. Okay. Jacob's first cut, he's cutting it in half. So we'll draw that line right down the center. Now we have our pizza in 2 halves. Now he's going to make his second cut. So I'll just change colors. And he's going to cut those pieces in half. So he had 2 pieces. He's cutting each of those 2 pieces in half. So now he has 4 pieces. Then on that third cut, he's going to cut each of those pieces in half. So we cut those. So we cut those in half, and then we also have to cut this in half too. All right, so now my pizza's in 1, 2, 3, 4, 5, 6, 7, 8. So these pieces are 1/8 each slice. Originally we had 1/2. Each piece of pizza was 1/2 of the original size. Then the next cut was 1/4 because there was 4 slices, so 1/4. Now our pieces, we have 8 pieces, so each piece is 1/8. And then we'll cut again. Actually, let me list these. So our first cut, we had 1 whole pizza. Then we had cut into halves. Then we had cut into fourths. Then we had cut into eighths. Now let's cut these eighths in half and see what happens. So we'll cut this piece. And then we'll cut this piece. Then we'll cut this piece. Then we'll cut this piece. And I think that's it. Okay, so now how many slices do we have? We have 16 slices. So each piece is 1/16 of the original size. Okay? And then I'm not going to draw in more slices because it's going to get really messy really fast. What do you think our next slice would be? Look at the pattern of what's going on and try thinking about what the next term would be. For part A, think about the size of each slice in relation to the whole pizza. Describe the pattern. Well, after each cut, each slice is half of the size of the previous cut. Part B, determine the size of each slice compared to the whole pizza after the next 2 cuts. Okay, so this one right here, this was our first cut. This one right here was our second cut. This was our third cut. This was our fourth cut. So we've already done the fourth cut. So fourth cut is 1/16 of the pizza. So each slice, this slice right here, is 1/16 of the whole pizza. 1 slice out of 16 pieces. Now, I asked you to think about, what do you think the next cut will be, the 5th cut? And if you guessed 1/32, you would be correct of the pizza. Because if we're looking at our pattern here, and we're looking at the denominator or the bottom of the fraction, each time we cut each piece in half, the bottom or the denominator doubled. So from 2 to 4, 4 to 8, 8 to 16, those are all being doubled. So now we're going to double 16, which makes 32. So if I cut each of these 16 slices in half, I'm doubling the bottom, the denominator. I'm doubling the denominator. So 1/32 of the pizza. Part C, represent the size of each slice compared to the whole pizza after each of the first 5 cuts as a numeric sequence. Include the whole pizza before any cuts, then represent using the table of values. Okay, so after our first cut, we're going to have 1/2. And then we'll have 1/4, 1/8, 1/16, and 1/32. So first cut, second, third, fourth, and fifth. Now, they also asked us to include the whole pizza before any cuts. So this would be our starting point, our initial value. And remember, initial value is not the first term, it is the 0th term. It'll be the y-intercept. So that's where we start. We start at 0 on our graph. So we start with one whole pizza. After the first cut, we're broken into halves. After our second cut, we have 1/4. Third cut, 1/8. Fourth cut is 1/16. And after the fifth cut, each piece is 1 out of 32 pieces. Moving on to number 10, which is actually our last question here. Miranda's uncle collects rare coins. He recently purchased a rare coin for $5. He claims that the value of the coin will triple, which is times 3, each year. So even though the coin is currently worth $5, next year it'll be worth $15, and in 2 years it'll be worth $45, and in 3 years it'll be worth $135. So each year we triple it, we times it by 3. Think about how the value of the coin changes each year. Describe the pattern. Well, I just told you if you were paying attention. So each year the value of the coin is 3 times greater than the year before. We're multiplying by 3. We're tripling the value. So however you want to word that out, that's up to you. Let's write that answer though. All right, part B, determine the value of the coin after 4 years and then after 5 years. So after the 4th year, our coin will be $135. We're tripling it, which will give us $405. And then after 5 years, so after that 5th year, we're going to take that $405 that it was worth in the 4th year, and we're going to triple it. And now that same $5 coin is worth $1,215 just by doing nothing. And the last part, represent the value of coin after each of the first 5 years as a numeric sequence, include the current value, and then represent the sequence using the table of values. So after the first year will be our first term, so it'll be worth $15. And then the second year, it'll be worth $45. The third year, it'll be worth $135. Fourth year, $405. Fifth year, $1,215. We also want to include the current value, which is, we just bought the coin, so it was that initial value of $5. And just like the example before and the example before that, we're going to include the 5 as our initial term, our y-intercept, so the 0th term. And then after the first year, it's worth $15. After the second, $45. Third year, fourth year, and 5th year. So like I mentioned before, we will be graphing these, not today, but we will eventually be graphing these. So if you understand what these term values are representing and you kind of already have a clue of what's going on, that these are ordered pairs, x, y, that will really help you in our next lessons.